I wanted to add 2 more examples just to give you a little bit of caution. These are just like the previous 6 you looked at, where I'm giving you sequence formulas that are explicit. This is an explicit formula because it will give you any term in the sequence. As long as you know the position, you can find what any term is. Likewise, this is also explicit. And I'm asking you to write for these recursive formulas. So, recursive formula, what is it? Well, this one looks a little bit different than that last example, number 6, that we saw. And what's different about it is, the previous example, we saw something like the first term plus a difference times n minus 1. We don't see any multiplication by n minus 1. So, I think what happens is a lot of times people realize the first term is what you see first. So a lot of people think the first term of this sequence a sub n is 5, but it's not. And it's because it's not in that form where you have the first term plus d times n minus 1. We don't have times n minus 1, so that is not the first term. So how do you find the first term? Because you do need the first term. If you're writing a recursive formula, the first part is the first term equals something. Well, the way you go about finding the first term is by using this. Right here, that little 1 tells you the first term happens when n is 1. So if we want to write the sequence out to see what some of the terms are, the first term happens when n is 1. Let's put 1 in for n. 1. 7 times 1 is 7. 7 plus 5 is 12. The first term of that sequence is 12. It is not 5. What the heck's going on in this sequence? Let's see what happens when we're looking to get the second term. Well, we let n be 2 for the second term. Put in 2. 7 times 2, 14. 14 plus 5 is 19. Let's get the third term, and then we'll get the fourth term, and then we'll step back and look and see what's going on. The third term happens when n is 3. 7 times 3 is 21. 21 plus 5 is 26. The fourth term happens when n is 4. 7 times 4 is 28. 28 plus 5 is 33. So what's going on? How is this sequence going from one term to the next? 12 plus 7 is 17. 19 plus 7 is 26. 26 plus 7 is 33. So now maybe you're realizing, oh, that 7's involved in multiplication by n. If I see plus 7 times n, it probably means I am adding 7. And you are correct. So let's write the formula for this sequence. Now that we see the sequence and we understand how it's being built, we can say the first term is 12, and we can say the new term is the previous term plus 7. Right there. There's your recursive formula for that given formula for a sequence. What about this one? Oh my God, we got an exponent. I hope you remember from talking about geometric sequences, if you see exponents, it probably means we have a geometric sequence. Geometric means we're multiplying by a constant ratio. Well, before we go about writing the sequence out for this, maybe let's build the sequence, because that seemed helpful in that last one. So let's get the first 4 terms of this. So the first one happens when n is 1. Let's let n be 1. 1 minus 1 is 0. 3 to the 0. Any number that's non-zero to the 0 is going to be 1. 4 times 1 is 4. Let's get the second term. The second term happens when n is 2. Let's put in 2. 2 minus 1 is 1. 3 to the 1 is 3. 3 times 4 is 12. Let's get the third term. Let's let n be 3. 3 minus 1 is 2. 3 to the 2, 9. 9 times 4, 36. Let's get our fourth term. n is 4. 4 minus 1 is 3. 3 to 3 is 27. 27 times 4 is going to be 108. So what's going on here? It sure looks geometric because it's starting at 4 and very rapidly going up to 108, so we're not constantly adding. You're right in that observation. Well, what do you multiply 4 by to get 12? You multiply by 3. What do you multiply 12 by to get 36? You multiply by 3, and you'll never guess what you multiply 36 by to get 108. It is 3. And look, you have multiplication by 3 to an exponent. The exponent is for representing repeated multiplication by 3. So if you see a base of 3 and an exponent, it is probably going to be multiplication by 3. So the recursive formula for this one is going to be our first term is 4, a sub 1 is 4, and our new term is our previous term times 3. There it is. Now, if you see one in this setup where you have to the n minus 1 and you have a number out front with a base to the n minus 1, this is going to be your first term, and this is going to be your constant ratio, that value right there. If we change it to look like something like a sub n is 4 times 3 to the n, it is going to still have a constant ratio of 3, but the first term is not going to be 4. The way you're going to find your first term is by letting n equal 1. Well, when you let n equal 1 in this one, 3 to the 1 is 3. 3 times 4, the first term of a sequence that would have that formula, the first term would be 12. This one has a first term of 4 because we see that n minus 1. So watch out for that.